Hi everyone, welcome to Family Maker Camp. I'm going to try this one more time now that we have everyone with us. Hi everyone, welcome to Family Maker Camp. My name is Ryan Jenkins and I'm the co-founder of Wonderful Idea Co., a design studio that's exploring art, science, and technology. Today we're going to be working together to build some ping pong ball microbit machines. We're going to be doing a lot of fun experiments. We're going to be working with some materials. We're going to be testing out some technology. But before we get started, I wanted to see who all is joining us today. So if you could please introduce yourself in the chat bar. I will be monitoring the chat throughout this entire project. And please let us know your name, where you are, and your favorite tool for tinkering at home. And I'm also going to be using the chat bar through this entire webcast. So if you have questions, or if you have comments, or if there's things that you want to ask to the community, please post that in the chat and I will try to respond live on the air. Cool, great. And I see some people are already entering, JP is already entering some things in the chat, so this is great. So this is my second time joining the Family Maker Camp. I'm really excited to be a part of these experiments with making and tinkering at home. I've been collaborating with Make and Make Magazine for a long time, and this summer I've been doing a lot of experiments with tinkering school in San Francisco, California, remotely to do online summer programs. And the project that we're going to do today is actually inspired by one of the kids in our summer online Code to Cardboard program who was working on creating wall-based ping pong ball runs. So just wanted to, before we get started, just wanted to mention that Family Maker Camp is bringing all different kinds of projects for people to do at home. We have tons of different presenters, tons of different topics, whether you're interested in paper airplanes or magic tricks. We are sharing these things online for you. If you're interested in this, please sign up at makercamp.com. Also, if you go to make.co, you can become a member of our community. So a couple of things just to keep in mind before we get going building our ping pong ball machines. One is that we're going to be tinkering with some materials today, and when you're working with these sorts of projects, things don't always go exactly according to plan. I think for sure with this video stream, things might not go according to plan. Definitely with the tools and materials, these are all things that we are going to be experimenting and working with. As well, I might have some things that you don't have. You might have some recycled materials that I don't have. And, part of tinkering at home is making do with what we have available to us. And like I said before, all ideas are worth trying. So if you want to experiment with something crazy, some weird idea, something that is unexpected, please also, give that a try and shout out in the chat and let us know what you're working on. And I see David from Tennessee is joining us, Shannon from Arkansas, JP from the UK. So it's super excited to see all of the people from all over the world who are joining us today for our experiment. So just for those of you joining us late, my name's Ryan Jenkins. I'm from Wonderful Idea Company. I'm currently in Vancouver, Canada, but we're doing projects remotely and all over the world, experimenting with art, science, and technology. For our ping pong ball machines today, I wanted to show some of the materials that we will be using as part of our projects. And all of these materials are common items that you can find around your house. I think especially now that we're all at home tinkering, these are things that you can collect and you can find. I'm going to put the list in the chat bar again, and I'm just going to show some of my favorite things. One is cardboard. So we're going to use a lot of cardboard for our project today. Cardboard's one of the most versatile making materials. You can, create it to be any shape you want. You can cut it, you can glue it, you can tape it. So cardboard's one of our favorite things to work with. Another thing that I like to collect is all kinds of different small food containers. So say I have a little yogurt container that I'm going to be using for the track or for the ball catcher, and I have this tuna box. Little small paper boxes are really nice for stands or for blockers for our ping pong ball machine as well. I have some of these toilet paper tubes that I've cut in half, and these are great tracks. Toilet paper tubes, or dirters as they are technically called, are a great material to use. We have aluminum foil that we're going to use a bit later when we start experimenting with the microbit, creating switches. I have this plastic bottle that actually makes a great funnel. And as well, we have a bunch of ping pong balls. So I decided for this project to use ping pong balls to travel down the wall. Because a ping pong ball is really light, and since we're going to be working on the wall today, we need something pretty light so that all of our parts will be able to stick up on the wall. So I'm just going to move this stuff out of the way real quick. And yeah, I can show you behind me up here. Hopefully you can see this track. And just to give an idea of what we're doing, I made a quick example this morning of some cardboard tracks that go into a little, that go into a little yogurt container that's down there. So I have my ping pong ball over here, and we're going to put it down the track. And hopefully, of course it doesn't work. First, it's gone a little bit funky, but I'm going to put the ping pong ball down the track, and it should go down and land right in our yogurt container. So, hopefully you are ready to start getting started making your own ping pong ball track. We're going to start simple just by building tracks and putting some recycled containers up on the wall. But in the second half of the webcast, we're going to add some computational or some digital elements as well to the process. So the first thing I wanted to show is just how to build a track that works well on the wall. This is the kind of the main part of these marble machines. There's a lot of ways to customize it, but I just wanted to show how to do that so we all kind of are able to build something on the wall. And to do that, not only do I need all these materials, but I also have some tools that I'm using as my project. I'm going to use some masking tape. Also, I'm going to use a hot glue gun, as that's one of my favorite tools for at-home tinkering. I also have some cutting tools like scissors and a utility knife, a box cutter. So these are just some of the tools that I'll also be using as part of the project, either to attach pieces together or to cut and shape the cardboard to work as part of our marble track. So to make our initial tracks, I'm going to need a couple things. I'm going to need some big strips of cardboard. So I already cut a cardboard box into some long strips. I mean, you can go as big or as small as you want with these cardboard strips. One thing to keep in mind is the direction of the cardboard. So just like wood, cardboard has a grain, and that will affect how it's used. So in this piece, the grain's going straight, so it's it's easier to kind of curve and bend horizontally like this. In this piece, the grain is going up and down. So for this, I can bend it and curve it a bit more and make a little ramp or a track or a little jump with the pieces of cardboard. So I'm going to start with this longer piece, and to attach it to the wall, I'm now going to get two squares, so two small squares of cardboard that are about the same width as the as this piece. And I might need to cut this just a little bit. So I have two pieces. Right now they are just about square or like little rectangle shaped pieces. And what I'm going to do to make these work well on our marble machine wall is cut off a little bit of an angle of these pieces so that one side is tall and one side's a little bit shorter. I'm not exactly sure what you call this shape. It's sort of some sort of a four-sided shape that has two parallel sides with one short and one long. If you know what the shape is called, you can write it in the chat. I forget it, but I'm going to make two of these pieces. And what this is going to do is that this is going to help me angle my piece of cardboard so that when it's attached to the wall, it will be at an angle so the ping pong ball will stay close to the wall. So what I'm going to do for this one, I'm going to just use my trusty hot glue gun and attach this piece. Oops, and I think my glue gun got stuck. Oh no, my power went out of my glue gun. That's okay. While it heats up and while I plug it in, oh no, my power strip on my glue gun somehow got a fuse blown. Okay, here it goes. So I can also attach this just using tape. So I'm going to use some masking tape to attach these little small pieces to my marble machine track. And if you're just joining us, we are building a ping pong ball marble machine track. We're starting out with some analog materials, with some cardboard and recycled materials. And later on, we're going to be adding in some computational pieces. We're going to be experimenting with microbit and also with some speakers and sensors and some other parts that we can use to make our project a little bit more technological. So what I just did is I attached my two small pieces onto the bottom. There are these little shapes. I want to get the angle right here. But there are these little shapes that are tall on one side and short on the other. And the next step is that I'm going to add a little bit more tape, and I'm going to put two pieces that are each on the short side of the track. So I can put one on one side and one on the other. I'm going to do this on the other side as well. And now I can start to put this completed cardboard DIY marble track onto the wall. So let's go back to our wall. We have our track right here with the little angled pieces. And I'm just going to put this at a kind of a slight angle. I'm putting the short pieces onto the wall. And now we've added an extra element to our marble run. One of the most important things to do as you are building this marble machine or ping pong ball machine is to test it out and keep trying and experimenting different ways of building and testing. So since I just added a new piece up there, I'm going to put a ping pong ball on, test it out, and it actually went all the way from the top to the bottom. You probably want to mix things up a little bit so that, you don't only have cardboard. There's plenty of different ways to build things as part of your marble run. So I'm just going to show one more is this sparkling water bottle that I have. I basically cut off the bottom and cut off the top and turned it into a little funnel or a little circular ramp for the ping pong ball to go down. So what I'm going to do now is get some big pieces of tape and put those around my sparkling water bottle and put that as another element in our marble machine run. I'm going to take the yogurt container off for a moment, and I'm going to put this water bottle onto the wall. I'm using masking tape here. It seems to be pretty good, like it's not taking off any paint in the wall. If you're really worried about making a mark on your wall, you can also use blue painter's tape. That's another really good material that you can use to make sure that as you are building with your marble run, it doesn't, scrape anything off. So now I just added this little green part, and what I'm going to do is test this out one more time and see if, so here you might notice the ball didn't quite go into the green funnel. That's okay. I'm just going to lift this up a tiny bit. Luckily with tape and with these materials, it's really easy to make adjustments. So let's try it one more time and see if that will work. All right. So it went through the green ball. It fell on the floor, but that's okay because I have lots of ping pong balls available for testing. So that is the starting point of how you can build a marble machine track on the wall. Like I said in the beginning, you can use all kinds of different materials. The options are really endless for how you can experiment with just recycled materials, plastic containers. One thing that I didn't get a chance to use yet, but I probably will use later on, are these little paper containers. Those are a great thing for either blocking the ball if it happens to be moving a little bit too fast, or being used as a stand on the marble machine wall. If you have any questions or tips or comments about building just the physical wall-mounted marble machines, I would love to hear those in the chat bar. If anyone is experimenting with a different kind of material or has suggestions for parts that we can use as part of this project, please type those into the chat, and we can, I'll share out what people are writing in there. And I see Dave from New Mexico is with us, which is great. We have Sienna from California. And please also continue to introduce yourself in the chat and say hi and ask any questions or comments. So just this project, just building a ping pong ball run on the wall using masking tape, cardboard, and recycled materials, I feel like this could be an endless project. You could work for days to make this a really complicated machine with loop-de-loops and elevators and, making it go slow, making it go fast, doing all kinds of different things. But one of the interesting things that we've been exploring this summer is adding in some digital components to our physical tinkering creations. And I'm just going to turn down my volume a bit because I think it might be a bit loud. I get excited when I think about all the possibilities of connecting physical and digital parts. So the main tool that we like to use, that we've been using this summer for these experiments, is called a microbit. And a microbit is a small microcontroller. It is, I'm going to get it on the screen right here. Cool. So it's a small microcontroller. It was developed by the BBC in the UK, and it is a small computer that you can use to control things in the real world. So you can use the microbit to control inputs like switches and sensors. There are buttons that are on the front of this board. This has an accelerometer so it can tell when it's being shaken or when it's being tilted. And you also can use the microbit to control things in the real world. So we can use the microbit to control things like speakers, LED lights, and small servo motors. And those can all be things that really expand the possibilities for these marble tracks. And oh, cool. And so Aparna in the chat was just mentioning also this idea of using corrugated pipe. So using pipe with little folds or little ridges for adding sound elements to the machine. So I think that's just one other example of how these marble ping pong ball runs, can go in all kinds of different directions. So instead of a, ball race, really this thing on the wall could become a musical instrument with bells and corrugated pipe and, different metal objects that make really beautiful sounds. And we have some other watchers from North Ontario, from Atlanta, Georgia. So keep introducing yourself in the chat. It is great to see. It's great to see everyone joining us. And and so Sienna was just asking, what if we make the ping pong ball conductive and have it complete circuits around the run? And I'm glad you asked that because that's one of the things that we're going to be experimenting with the microbit is adding a switch into our ping pong ball machine so that it can trigger something as part of the contraption. So like I said, we're using this microbit. This is a microcontroller, and it is. I really like it because it's really flexible. It adds these little holes here that you can just easily clip an alligator clip to. We're going to be doing that a bit later on today, and it is also really easy to get started programming the microbit. I'm going to show. Hopefully, you can see my screen. So I'm going to show the idea of coding the microbit. I like to use this website called Make Code, and this is a really friendly and easy way to get going designing programs on the microbit. And this is a block-based programming language, so if you're familiar with Scratch or other block-based coding languages, you can use Make Code as well to design your projects. There's blocks like a forever loop. There's input blocks. So in a bit, we're going to use this one called pin pressed. There's music blocks, so we can connect the a speaker to the microbit, and as well there are lots and lots of other things to explore. So the first thing that hopefully people saw that. This is my first time using OBS, so I'm just experimenting a bit with how to go back and forth between the coding and the real world. So for the first digital element, we're going to do 2 digital elements as part of this machine. Of course, the possibilities for doing digital tinkering elements with your ping pong ball machines are really endless. But I just wanted to show a couple ideas. Some of the other things that we're going to use are little wires. So we have these small, and I'm going to put the materials list up on the board for the digital materials. So give me 1 second. So some of the digital materials that we're using include using these little jumper cables as well as alligator clips. So it's really easy to connect things to the microbit using jumper cables, alligator clips. I even have some that are a combination of alligator on one side and a jumper wire on the other side. We're going to be experimenting with adding a speaker onto the microbit. So I got this little speaker on Amazon. It's just maybe $3 or $4, and it can connect to the microbit. It's actually it's not the loudest speaker in the world, but it works pretty well for our purposes. We're also going to use some battery packs. I have one here for my microbit. And as well, later on, we're going to be programming a servo motor, which is a small motor that you can move using the microbit. So the 2 things that I'd like to experiment with for the rest of our time today, when we're adding the digital side to our ping pong ball machine, is creating a device that can trigger the ping pong ball to run, and also creating a conductive switch that can play a song at the end of the marble race. So first, what I'd like to do is show you how to connect the pieces to the microbit. And when we're connecting elements to the microbit, we're going to use these little pieces on the bottom of the microbit. Oops, let me make this a little bit bigger. We're going to use these little parts on the bottom of the microbit, these little holes, and those are called pins. And a pin is basically a place on a microcontroller where you can connect an input or an output to the machine. Like I said, the microbit is really nice because it gives us little holes on the front that we can just clip alligator clips in and can add in any kind of components just by using the alligator wires. So the first thing that I'm going to do is connect a switch. And so when I have a switch, basically all I mean is 2 pieces of metal that you can put together and conduct electricity through those 2 pieces of metal. So I'm going to attach my switch to pin 1 on the microbit. And what that means is I'm going to put 1 piece of the metal, I'm going to attach to the alligator clip and put it on this number 1. So this is going to be attached to pin 1. And I'm going to put the other piece of metal. Let me move this over a little bit so it might be a little bit easier to see. I'm going to use this other piece, and let me just kind of arrange things a bit more. I'm going to do the other metal piece, and I'm going to attach that to the ground part of the microbit. And so what this is doing is it is triggering something to happen when these 2 pieces are connected. I actually already have a program on the microbit that I'm going to show you how to make, but it's something that you can even see now that when I push these 2 pieces together, the lights on the microbit start flashing a little bit. And that's because I'll show you in a second, but I programmed the microbit to respond when these two pieces of metal connect with each other. One thing that Sienna was asking is, can you make the ping pong ball conductive? And you definitely can, and that could also complete the circuit. So if I could wrap the ping pong ball in aluminum foil, and if I had these two switches next to each other, and the ping pong ball went in between them, I think that also can trigger the switch. Let's see if it'll work again. So basically, any way that these two metal pieces can touch each other, either by touching each other, by having a third piece of metal like a ping pong ball go in between, or even by using our hands. So actually, our hands are conductive, and if I just touch both of these pieces, the electricity will go through my hands and actually turn on the lights on the microbit. So the lights on the microbit are nice, but I want something that's a little bit more exciting for my project. I'm thinking that this ping pong ball machine behind me can become some sort of a door alarm. So I'm also going to attach a speaker to the microbit. And so this speaker, I got one that has two little jumper cables, two little socket jumper cables here. And I have two cords that have an alligator clip on one side and a jumper cable, the little pin part on the other side. And I'm going to use that to connect my speaker to the microbit. So I'm going to go from the black wire of the speaker. Oops, let's see if I can do this again. And yeah, in the chat, if you've experimented with microbits before, let us know what you've done using a microbit. There are so many different possibilities. Connecting them to ping pong ball run is just one idea, but there's tons and tons of different ways to do it. So what I'm going to do here is I've attached one alligator clip with a black wire, also to ground. There's only one ground position on the microbit, so I had to attach two clips both to ground, but I'm just kind of clipping one of them sort of horizontally and the other one down, which works okay. And then for this, the red side of the speaker, I'm going to attach that to the pin 0 on the microbit. And so the speaker on the microbit always has to go to pin 0. They've just programmed it where it always is on pin 0. And so now I'm going to show you this code in a second and how to make it. But now when I trigger the switch, we should have lights and sound playing on the microbit. So hopefully you can hear that. So now when this switch is triggered, we have a little light and also a sound. So basically this is this program that I've already loaded onto the microbit. And now I'm going to show you how to make this program using make code. So let me go back to make code, and hopefully you can see this. And great. So I'm going to go back to make code here. And so basically with make code, anything that I put in this big gray area, that is going to be the part that gets uploaded onto the microbit. And so to make this program using the switch and the speaker, there's just a few blocks that I have to use. The first one is this forever block. And the forever block is really important because a computer needs to know, or a microcontroller needs to know, when to run this program. So for the forever block, that's telling it to always be checking the condition. To make the condition, I can go into logic, and find this if true statement. So for an if true statement, that's checking to see if something is true and then doing something with that information. So the thing I want to check is my switch being triggered? And since I attached my switch to pin 0 or to pin 1, I can use this on pin pressed. And so I'm going to drag over this pin 1. I'm going to change this to pin 1 pressed. Oops. Pin 1 pressed. And then anything inside of this mouth, that's what's going to happen. So I'm going to grab some lights in the basic. I want it to show all the LEDs on, and I want it to play a song. So I'm going to make it play a melody. This is a really nice tool that the microbit has to play a melody. Then I want the LEDs to turn off. And I also want to repeat that twice, just to make sure, in case I miss it the first time. So here's all the code that's on my microbit to make this work. It says forever, if pin 1 is pressed, then, so if the switch on pin 1 is connected, repeat 2 times, blink the lights, and play the melody. So you can upload that or download that onto your microbit. And then it should have the same effect. So let's go back to the table, and hopefully now you can see what that code looks like in the real world here. So now the switch is connected to pin 1. So on pin 1 pressed, it blinks the light, it plays the sound, and so now this is something that I can put into my marble run over here. So great. And so let's do that. Let's put this into the marble run. Actually, instead of this switch, I'm going to change it for a little bit of a different option. If I can find this piece, which somehow has disappeared from where I am right now. Oh no. Okay, well I can't find that piece that I need, but that's okay. And yeah, so great. And so what Mike also mentioned in the chat is we can use a on pin 1 pressed block, and that's exactly true. It's in the purple blocks. It's an input. And one of the things about make code, or just about coding in general, is that there's always more than one way to do different things. And like Mike said, it might behave a bit differently. And that's one of the really fun things about building and experimenting with these devices, is to figure out, what are different ways that we can accomplish the same task using these parts. So I'm going to put this switch aside. I'm going to quickly show one more possible thing that we can add into our ping pong ball run. Then we'll go back to the wall and we'll add these pieces on as this sound goes one more time. So the other one that I'd like to show is how to build a piece with a servo motor to trigger the ping pong ball run. So oops, and my sound is still going on because my switch is still connected over there. So for this one, I'm actually using a new piece on the microbit. I'm going to use this little extra board that's made by SparkFun, and it's a breakout board, and that gives us a little bit more flexibility using the microbit. And if you're just joining us, what we're doing is we are building a oops, let me change my camera a bit. We're building a wall-mounted ping pong ball machine. we have some ping pong balls. It's going to go down the track and hopefully work here. I'm going to catch the ball in my hand. It's going to go down the track, and now we are building in some digital elements to those machines as well. So one other one that I want to show is connecting a motor to trigger the machine. And the motor I'm using is these little servo motors. These are a really cool motor that you can control the angle using the microbit. I'm just using this little red breakout board, this SparkFun board. Basically what that does is it just changes these little parts on the microbit, all these little metal connections, into little pins on the bottom of the breakout board that you can connect the jumper cables to. There is one sort of issue using the servo motor, and that's that it needs a little bit more power. So there's kind of a special way to connect the servo motor and have it have its own battery pack. So we'll have one battery pack that's attached to the microbit and one battery pack that's attached to the servo motor. This is a bit complicated. If you check later on our website on wonderfulidea.co, I will show how to do this a little bit more detailed along with the video. But just for now, try to follow along, and we'll have a fun trying to connect the servo motor to the microbit. So the first thing we want to do is connect the battery pack, our second battery pack, to the servo motor. And so what I'm going to do is go from the red wire on the battery pack to the red wire of the servo motor. And what that's doing is it's giving us power from this battery pack directly to the servo motor. Also on my battery pack, I'm going to need to do something with the ground, with the black wire. So I'm going to connect that one into the microbit. So we're going to share a ground on the bottom of the microbit here. The next thing we're going to do is, like I said, share a ground with the servo motor. So I'm going to attach the brown wire of the servo motor, which is the ground, and I'm also going to attach that to the ground on the microbit. And like I said, I'm using this little red breakout board. That just makes the connections a little bit easier to go from the jumper cables on the servo motor to the microbit. And then the last thing I need to do is connect the signal of the servo motor so that the microbit knows where to connect the servo motor. So I'm going to use this yellow wire to connect the yellow wire of the servo motor to pin 0 on the microbit. Servo motors come with these little plastic pieces. These are called servo horns, and they fit right onto the servo motor. And then that's a piece that moves on top of the servo motor. I kind of like to make my own custom servo horns. So basically, I just took the servo horn that was in the pack, and I glued on this little cardboard straw. And that's something that you can use just to make things a little bit smoother as part of your machines. So I'm going to put that onto the servo motor. So this is what should move. I'm going to plug in the second battery pack to the microbit. And let's test out of code. Let's test out our program. And in a second, just like the one I was doing before, I'll show you the code that makes this work. But let's just see how it works before I show you on make code. So what this should do is when I press A, my servo should, let me get in the right position here, should go to 90 degrees, wait 1 second, and then go back to 0. So I'm going to press A. And it's not working. I'm wondering if my battery pack is dead. Let me try to switch these batteries because a little bit ago I was testing my battery pack, and for these servos to work, you really need a lot of power. It needs probably more power even than I'm working with. I'm working with sort of my DIY tinkering kit that I had in my luggage. But let's see if it will work if I plug in the other battery pack here. Yeah, I heard something going on. So when I press button A, it's going to move it to 90 degrees and then back to 0. 90 and then back to 0. And what this is going to do is this is going to release the ping pong ball at the front. And Howler was asking, which shield is that? I'm just using a SparkFun breakout board. I can put that in the chat. It's basically all it does is takes the little pins on the front of the microbit and gives you little header pins so you can attach to all different components to the board. I'm going to put the link to the breakout board in the chat so you can also see. I got on SparkFun. There's so many different shields and components for the microbit. This is just one that I like to use so that we can do more components using the microbit. So before we attach this onto our marble machine, I'm going to show you the code that makes this work. So when I press button A, it goes to 90 and then down to 0. Let's see. Oh, and Michelle, hey Michelle. Michelle's asking why I put this cardboard tube on the servo. That will become a little clear in a second, but basically we are building a marble machine track, and so this servo will be the thing that releases the ping pong ball. So I just wanted to make it a little bit bigger, and so I hot glued a little straw onto the servo horn. And that's something that I think is really fun to do, whether you're making marble machines or robots. I mean, the servo motor comes with, this is going to be a bit of a digression, but the servo motor comes with these little tiny plastic pieces. But something that's really cool is you can just use hot glue, and like if I wanted to make a big spinning robot, I could just attach, let's say, a yogurt container to the little servo horn here. And let's try this one. And so now I have a, spinning yogurt container that could be something different for my machine. Oops. Yeah, there it goes. So I really like to make custom servo attachments. When you buy a servo motor, it comes with these little plastic pieces, and I just hot glue all kinds of stuff to them and make my own wheels, make my own levers, really customize how to use a servo. And cool. So let's. And I'd love to see other experiments with that. And cool. And yeah, thanks, Mike. Mike's talking about there's so many different things you can do with the microbit and also with servo motors. So let me just show the code I'm using to program my servo motor. Let's go back to make code here. I think we should be on here now. So I'm saying when I press button A, I'm going to move the servo. So I go to input, I get this on button A pressed. And then to program the servo, a trick that I like to use is to use these extensions. So I go to advanced and then extensions and then click on this servo library. And this gives us some new blocks that you can use to program your servo motor. So I can go here and say set servo angle to 90 degrees. You always want to pause, so you give your servo time to move. I'm going to pause 1 second. Then I'm going to go back to servo and set my servo angle to 0. One trick that I like to use when I'm working with kids and doing these sorts of projects with the microbit is adding in some graphical feedback to the design. So often when we're building, we're not sure if the code is working or or what's going on. So what I like to do is, so when the servo goes to 90, I'm going to make a little 90 degrees sign. And when the servo goes to 0, I'm going to make a little flat sign. And then at the end, I can do a little smiley face just for fun. But basically, this is just giving us some clues that the code is working if we see these designs. Maybe the issue is with the servo motor. If if we don't see those images on the microbit, then that probably means that the code wasn't uploaded right to the board. And so this is just a way when you're troubleshooting, you can get some feedback about whether the code is working or not. So yeah, so just to recap, pretty simple code. We're just saying on button A pressed, set the servo to 90 degrees, show us this little picture, wait 1 second, and then show this picture and set the servo to 0 degrees. So just going 90 back down to 0. So let's go back to the board. Great, so awesome. And yeah, Mike's sharing some good stuff in the chat. So just to recap how this looks now that you've seen the code, when I press button A, it goes to 90 degrees, back to 0. And like I said, I have my little icon on the microbit that's going to show us what's happening, just to give us some extra clues about what's going on. So that was a really quick introduction to 2 things that you can do with the microbit. Now I'd like to try to put these onto my machine. Let's see if we can add these into our marble run and and see how we can turn this ping pong ball machine into a digital ping pong ball machine that can do different things for us. So you might have to make your own custom pieces. I earlier today built this little servo microbit holder to attach it exactly in the right place on the wall. I just got a mushroom container and some cardboard, and I'm gonna build my own little piece here where I'm gonna, let me go back to the screen. I'm gonna put my servo motor onto the, in between these 2 pieces of cardboard here. I'm going to attach the microbit to the front, and I'm just going to try to kind of get this into a little package so that we can put it on our wall and have it be fairly contained here. Let's see if this will work. And I'm going to put this the servo motor in between these 2 little pieces. I think it's gotten a little bit funky over the past hour or so, and I'm just going to add a little bit of tape to stick it in even a bit better. So now I have this little piece. It has my microbit on it. It has my battery packs on it. This was just a custom little mushroom basket piece that I made earlier today. Like I said, I'm going to attach my little piece for the microbit. Let's see how this will work. And now let's put this up on the wall and we can see how it will work. So basically, I'm going to put this underneath the first part of the machine. So maybe I'll put it here. Hopefully this will stick. I'm going to test it out before I put it in there, and oops, and this is going backwards. So let's try this again. Great. So let me try this one more time. I'm going to put this microbit on again, and it should over here. when I press the button, oh, and you know what I did? I put my microbit a little bit upside down. And while I'm switching the microbit, since I did it upside down, Gail is asking where to get the micro servo motors. Some of my favorite places to buy electronic kits, one of them is Adafruit, is a great site to buy all kinds of electronics. And also SparkFun is a good place to buy electronics like servo motors. If you want to go a little bit more in bulk, I found some cheaper servo motors on Amazon. And actually, they seem to work fairly well also. On Amazon, I think I can get about 5 servo motors for about $20, and they seem to work pretty well. So let's try this one more time here. I'm gonna, let's see, put this, as I drop the pieces, I'm gonna put this servo motor onto our marble machine, and let's see if it will work. Oh my gosh, and I totally have it in a weird one. And now I'm totally confused about which way this can go onto the machine. This happened. So now we're going to be actually just doing a lot of tinkering to try to make this work exactly right. So let me go back to my table here and see if I can press the button and get this to move up and down. And what's really funny is that I wanted it to go the opposite way. Let's try it like this. And Mike got his on Amazon as well. And did it switch again? Let's try this one more time. Sorry about this. I'm just trying to get my piece, my servo motor piece, to work so it can be the release for the ping pong ball run. So let's try this one more time. And it is totally backwards. This is the challenge of making something beforehand and expecting it to work in the same way that it did before. Now I'm confused about that, but it's okay. Let me try to see if I can just put this back on the wall and then we can figure out from there. So let me move this over a bit. We're gonna put this little piece up on the wall. I'm going to use some masking tape. Hopefully we can get this going. I know we don't have very much time left, but as I was saying before, this is the kind of project that can take weeks to get exactly the way you want it to. But let me try to see if I can put this little piece using some tape up on the wall, and we can at least have a trigger for our machine, and then I can show you how the little alarm will work at the very end. So I'm going to put this underneath the intro track up here. Let's see if we can get this working. Okay, that seems to be sticking. Now I'm just going to, let me see if I can move my camera a little bit more. Great. So I'm just going to attach this little servo horn that I made and see if I can put it in the right position so that it will, let's see. And it's going a bit backwards than I expected. There it goes. Okay, so I want it to be this way. That was my problem, is that I had my servo motor upside down compared to the right way that I thought it would be. So let me just tape this up on the wall. And as I'm doing that, I see Mike is also saying some physical stores to buy servo motors, like Fry's Electronics or Micro Center is a good place to go. I haven't tried that, but I think that makes a lot of sense. So let me just test this one more time. And it should go like that. Great. So let's try this one more time. We're going to put this servo motor back onto the board, and hopefully this will work. I press button A, and the servo motor goes. So let me now test this to see if we can actually get the microbit to release the ping pong ball on the top of the machine. So here we go. Oops. And it is a little bit funky. Let's try this one more time. Now this is the point where the masking tape is our friend. I'm gonna try one more time. I have the ball. I need to kind of hold it up a bit, but let's test it. The ball gets released. It falls off. Let's try one more time as I get another ping pong ball. And here it goes down the tube. Great. And goes through the little piece on the bottom there. So great. So for the last piece, I don't think we have time to figure out how to get it exactly onto the board, but I can show again, like the idea would be that since I have this other microbit piece with the switch, so now with my microbit and my speaker and my switch, when I press this switch, it plays a sound and does the sound. It does the sound and it shows the lights. So you know, I might keep on working on this and post it online later on. But what I would do is try to figure out a way to put these two pieces of aluminum foil maybe right here. We could try it real quick. I think nobody will blame us if we go a little bit over time. So let's just try it. I'm gonna put one of these pieces on the bottom of the plastic bottle. I'm gonna make a little shelf for the microbit. Let's see how this will work. And put that on the bottom as well. Thanks for sticking with us. This is a lot to do. Like I said, this project probably could take, you know, a few weeks to work on. And we're trying to do it in just an hour or so. But I'm gonna add one more little piece here and let's see if we can get this to go. I'm not 100% sure if this will work perfectly. But you know what? That's okay. Part of the tinkering process is, you know, experimenting and trying things out. So what I'm going to do is I'm going to put my microbit and speaker here on this little shelf that I just made. And I'm going to try to put the two little pieces of my switch underneath the little bottle here. And so let's see if we can arrange this. Plug my speaker back in because it fell. Let's see if we can arrange this so when the ping pong ball goes down, it will attach this. And what I can do is maybe I'll grab my other camera here and I can just show the parts now. We have our, hopefully you can see this okay. Yeah. We have our piece with the marble release. So if I have a ping pong, or the ping pong ball release. So if I have a ping pong ball, I put it up here and it's all kind of ready to go. And I press button A and it gets released, magic finger, and it goes down the track. And let's see. And it just hits that switch and triggers the sound. So it actually worked. I can't believe it. It actually connected these two pieces of foil together. Let's try that one more time just to see if we can get, I know my servo is a bit funky here, but let's try it just one more time with the servo motor. I'm gonna press the button. It's gonna release the ball with my magic finger, go down here, and it almost, there it goes, triggers the switch. So now is the time where I would be doing a lot of little experiments to tweak and to change this marble run to work the way I want it to. I could start adding story elements. So instead of just a marble machine, this could be a alarm so that my little brother doesn't go into my room and mess up my stuff. So I could have it be triggered when the door opens and a light sensor is triggered on the microbit. That plays music. Another really cool thing that you can experiment with are using the radio function for the microbit. So microbits can communicate with each other. So you can experiment with, sending signals from one microbit to another. There are so many different ways that you can, add in digital elements to our tinkering experiments. So I think with that, I would love to continue the conversation and hear what you're trying, what stories you can tell with your digital ping pong ball machines, what materials you're using. You can get in contact with me on Twitter at Ryan E. Jenkins, also at Wonderful Idea Co. You can check our website, wonderfulidea.co, for more fun ideas and inspirations about how to work and build with physical materials and digital tools like the microbit. And just again, thank you so much to Maker Camp and Make Community for setting up this webcast. It's so fun to experiment and build with everyone. Even though we're still at home, it's really fun to be experimenting with similar projects and sharing ideas with the maker community. So, and thanks everyone for watching. Thanks for your great ideas and advice in the chat. And until next time, I'm Ryan from Wonderful Idea Co. Thanks so much for joining us today. All right. Bye, everyone. Thank you so much. Bye. See you next time.